I am Xavier Swamikanam, a board member of the Fulbright India Interest Group, a chapter of the U.S. Fulbright Association. Our mission is to advance cultural, scientific, and academic partnerships with nations in the Indian subcontinent. On behalf of our president, Ms. Mrinali Watson, and my colleagues on the board, I'm delighted to welcome all of you to today's climate chat featuring Dr. Rajani Panchang. Dr. Panchang is an assistant professor in environment sciences at Pune University in Western India and a visiting Fulbright scholar at Florida Agriculture and Mechanical University in Tallahassee, Florida. Her field of expertise is marine sciences. Our moderator today's session is the distinguished Dr. David Weindorf, a Fulbright alumnus and the executive director of the Research Service Foundation at Georgia Southern University. Dr. Weindorf, please take it from here.
Very good, thank you. Good morning to all. It is my pleasure to introduce Dr. Rajani Panchang, a distinguished oceanographer, paleoclimatologist, and environmental scientist whose work bridges marine geology, climate science, and coastal ecosystem research. Dr. Panchang currently serves as a Fulbright Column Climate Fellow at Florida A&M University and is an assistant professor, as aforementioned, at Savitribai Phule Pune University. Her research focuses on paleoclimate reconstruction, ocean acidification, sea level change, and marine bioindicators such as foraminifera, with strong emphasis on understanding human-climate interactions in coastal environments. Over the course of her career, she has led and contributed to major funded projects supported by India's Ministry of Earth Sciences, DST SERB, and international programs, all while participating in several oceanographic expeditions across the Arabian Sea and the Bay of Bengal. Dr. Panchang is widely recognized for her scientific leadership and outreach, receiving honors including the prestigious Fulbright Column Climate Fellowship and the Mani Shankar Shukla Gold Medal for outstanding contributions to micropaleontology. She has authored an extensive body of scholarly work spanning marine geology, paleoclimate, ocean circulation, and environmental monitoring, while also remaining deeply committed to science communication and mentoring the next generation of researchers. Dr. Panchang, good morning, welcome, and thank you so much for being with us.
Good morning so much, David, for doing this. It's an honor to be talking to you yourself, such a distinguished person. And I thank the Fulbright India Interest Group for thinking of me and inviting me here. Thank you so much.
Well, it's wonderful to have you. And we really enjoyed hosting you here at Georgia Southern University several weeks ago as well. It was a wonderful visit. So I've got some questions I'd like to dig into today for the benefit of our audience. And the first of those questions is as follows. Now, you've moved fluidly across disciplines from geology and oceanography to climate science and environmental studies. Looking back, what moments or questions most shaped the scientist that you've become?
Okay. I would not call that I have moved through different disciplines. I think all these belong to one interdisciplinary science, which is called the Earth System Science. And you yourself as an earth scientist will agree that we don't look at just the soil or just the geological component without realizing that the Earth, all these, the atmosphere, the hydrosphere, the biosphere has all stemmed out of the original, condensing Earth, which gave rise to these different spheres. And so even when I look at geology, I can see that it is an outcome of, an interaction of all the other components. So I would not say, I just think all these different disciplines have made me understand the Earth System Science better. And coming to how has it shaped me as a scientist? I think when I was a student of geology, one thing that always stuck with me, we as geologists are expected to look at the Earth's history spanning 4.5 billion years. And that's why when people talk about geologists, they think we talk about the past. And many times people are not interested in what's happening in the past. And but there was one thing that stuck with me. There was one principle, which is called the principle of uniformitarianism, which told us that a present is a key to the past. It tells us that whatever processes which are prevalent on the earth today have existed for time immemorial. Those processes might have changed in intensity and might have changed in space and time, but they continue to exist. So that stuck with me, and that told me that, oh, so should I be looking at these processes? Because I've always been a person, why, where, how? So when I look at something and I'm told that this is how it is, I've been a person who's been, wanting to challenge, is it? Could it not be like this also? So I think these were the questions which told me that, that how, for example, uh, if these processes exist, then since when have they existed? If oil and gas was made in the past, they should be continuing to be formed even now. Where are they being formed? Are they being formed in the same amount of? So when I've been doing this, I've seen that society is interested in what is happening today. If I look at thousands of years ago, I'll be able to predict what's happening in the thousands of years in the future. But if I look into the recent past, I will be able to find processes which maybe have an implication in the recent future. So that was my question, that how did my recent past look like? Though it is having a lot of human footprint and a lot of disturbance that humans are doing. But still my question was, how can I keep geology relevant? How can I keep my training relevant to make it useful for the future? So, so my main thing, that is what, these are the things, these were the questions that has made me the scientist that I am, trying to make myself relevant to application of my training.
Absolutely. Yeah. I mean, some of the things you were talking about there, the sphere theory, those are things that I've taught in my classes as well. The linkages in between the hydrosphere, the pedosphere, the atmosphere, the lithosphere, all of those systems interacting seamlessly. So I can definitely relate to exactly what you're saying. Now, much of the work that you do reconstructs past climates using microfossils and sediment records. Why is the deep past so critical for understanding today's climate dynamics?
Okay, what is climate? Okay, when climate, people will say lots of definitions they will give, but actually, climate is a product of the solar budget. That is how much of energy is coming in and how much of energy is going out. And this has changed throughout time. Okay, depending upon the amount of greenhouse gases given out by volcanoes or given the distance from the earth. We all know that the distance of the earth changes from the distance of the sun from the earth changes according to seasons. It changes according to the axial tilt, which changes with seasons. This also changes throughout time. There are records which say, okay, just coming to that. So, climate budget is throughout the past, if you talk to geologists, they say climate change is normal. There are records which say that after every 1 lakh years, or every 1 lakh years, the or 0.1 million years, the Earth moves into a glaciation, and again it comes into an interglaciation. So those are when major climate change effects have been seen, melting of ice sheets have been seen. There are also beautiful records of the past 3 billion years, which show that the Earth is naturally a greenhouse. That is, throughout the Earth's history, there has never been a single ice cap. The Earth tends to be a warm house. So then why is there such a hue and cry about the ice cap suddenly melting, sea level rising? So the geologists, or the hardcore geologists, said this is normal. Life dies, life again comes up, and this is a natural process and there shouldn't be any hue and cry. But I'm going to come to something, the same records that I'm talking to you about. There is this very beautiful record developed from sea ice and sediment records, 800,000 years record, which shows that the carbon dioxide has varied um, somewhere between 180 ppm to about 280 ppm. Okay, and that is the range that it has been for the past 800,000 years. But suddenly, there are records that somewhere in 1950, this concentration has gone up to 420 currently. So 1950 to just the past 75 years, it has changed. So it has moved. So 1950, it was about 300, and now it is 420. So one, there is unprecedented presence of carbon dioxide, which is the most strongest greenhouse gas contributing to global warming. That is something that we know that this is unprecedented. What makes it more interesting? I was talking to you about change in carbon dioxide from 180 ppm to about 280 ppm at the max. So about 80 ppm to 100 ppm increase or decrease happened over a time span of 30,000 years to 50,000 years. The rate of change was so low. But now thinking about the last 75 years, the increase, the rate of change has been like drastic. There has been 75 ppm. In 75 years, the concentration has increased by about 120 ppm. The rate of change, when climate changes gradually, ecosystems get a chance to adapt, to continue to thrive, evolve or migrate. But when climate change is sudden, it is a shock. And that is why I think we are currently calling it the sixth major mass extinction, the Holocene mass extinction, or the Holocene or the Anthropocene mass extinction. And that is where we are saying that in the past 75 years, it is human-driven climate change, and extinction has been almost 1,000 times more than background extinctions seen. That is why it is important to look at deep time, to be able to tease apart uh, the natural climate variability from human-induced climate variability. It helps us make realistic targets for policies, for climate funding, and because I believe that climate is an environmental, more than being an environmental issue, it's a developmental issue.
Yeah, absolutely. Well, and that carbon dioxide increase relative to when the Industrial Revolution started is really remarkable. And they often say correlation does not infer causation, which is true. But in this instance, I think the evidence is quite compelling. And, we might just let our listeners know as well, like how are we able to determine those carbon levels? And again, you mentioned it's from those ice cores that have been, sort of buried, frozen in time for hundreds of thousands of years, and we're able to extract that carbon and do radiocarbon dating and other techniques in order to determine that age. So now you've often said that foraminifera and pteropods tell stories, quote unquote. What are some of the most surprising or powerful stories these tiny organisms have revealed about oceans and climate?
Okay. Pteropods have been known as mollusks for a very long time, known as marine butterflies, very new on the paleoclimate scenario, okay, and not considered as robust, but it's developing as a paleoclimate indicator. But foraminifera have been around for a very long time, even in paleoclimatic reconstructions, giving us clues about climate. And so foraminifera have been very versatile, used in all marine, problems to solve. It is amazing that they have been around on the earth for the past 540 million years. They have changed in composition, in distribution, in abundance, but only because of these foraminifera, we have been able to reconstruct the past 100 million years of climate history. I think that is really amazing. Another thing is, it is because of this foraminifera that we have understood that water masses circulate. It is one ocean. Water from one ocean moves to the other ocean. Water from the poles comes to the equator, and those from the equator go to the poles. They also help us understand that the water sinks, the surface water sinks to the bottom, and it again comes out somewhere on the top. So it tells us about different processes into the ocean. Some very more beautiful things are they are the ones which tell us that when there is glaciation, the sea level drops. It also tells us that when there is glaciation and all the ice caps hold up all the water, the Antarctic waters can move in as close to the equator, which is like amazing. These are processes that they tell us about. it is so amazing that somewhere about 55 million ago, where we call it the Paleocene, Eocene thermal maxima, where there was lots of volcanism, that is when there was a rise in temperature, 8 to 9 degrees centigrade rise in temperature, where the poles were as warm as the tropics. And they could help us explain that alligators and palm trees were found in the higher latitudes or as far as the North Pole. So, I think these are amazing things which make us believe in so many. And for example, there are normal marine organisms or normal marine waters need oxygen, which is about 6 to 7 milliliters per liter, milligrams per liter. But foraminifera have been found, soft shell foraminifera have been found at the depth of 7,000 and 11,000 meters in deep oceanic trenches where temperatures are high, calcium carbonate is low, and pressures are as much as 1100 atmospheres. You find foraminifera in low oxygen zones or no oxygen zones. They have also existed and survived deep ocean acidification times. So they tell us how resilient life can be.
Yeah, absolutely. I mean, they are survivors. I'm thinking about those organisms we talk about as extremophiles, right? That can handle that extreme pressure or temperature variations. And you touched on ocean acidification, and that's kind of the direction I want to go next. This features prominently in your work. From your perspective, what are the most underappreciated consequences of ocean acidification? Is it scientifically? Is it societally? Other? I mean, talk about that a little bit.
Ocean acidification, what we all know is the pH will reduce. Right now, it is about 8.1, down by from 8.2 years ago to about 8.1. And this means about 30% increase in acidity. Just 0.1 means about 30% increase in acidity. So when we talk about that, we're talking about dissolving shells. You're looking at, because there's dissolving shells, there's prey-predator relationships which change. Some places the preys are over, so the predator has no food, a collapse of the ecosystem, dissolving calcium carbonate shells, increasing acidity, the oceans being sources of carbon dioxide rather than taking in carbon. These are things that are well known of. They also talk about change in reproductive cycles. Because there is ocean acidification, small larvae of mollusks and gastropods and organisms, they don't grow, they don't mature. Because they don't mature, then new offsprings and adults are not formed. When new adults are not formed, then they die out. There's a complete wipeout. So it also affects organisms, swimming potentials, attachment potentials. But something that is very, very interesting when I've been looking at impacts is, did any one of us know that because of ocean acidification, there's going to be more noise pollution in the oceans? What happens is low frequency sound waves, which are given out by mostly whale animals, mammals, they use low frequency sound signals to navigate. Similarly, you have navigation boats, ships, and oil exploration ships, which use the same. When there is ocean acidification, there is reduction in borate ion concentration. When there is reduction in these borate ion concentrations, they attenuate, they absorb the low frequency sound signals, making their traveling, it cuts off the traveling of these signals. That makes navigation easy for whales, okay, or even for our ships. But now with these borate ions going down, the low frequency sound signals are going to persist, and they're going to persist for a very long time. They're not going to get attenuated. They will travel for longer distances, disrupting the navigation. Okay, so this is something that is socially, and because of that, you have whales which go haywire, they get beached, they get lost, they can't go to where they want to, finding food or mates, prey predator, all this is affected. Another thing is what we as a society don't realize is we are only coral reefs. Coral reefs are going to start dissolving, then they are lost in habitat, which is one of the largest food, what do you say? It's the largest biodiversity, marine biodiversity, and that is not going to be there. It is going to cost all these shells. Again, when shells are not there, it also helps us not in the food industry. It is going to cause a dietary shift, food shortage, nutrition, like these shells and all are so commonly available for common people to harvest, but they are going to go down, and they're also going to cause problems in what do you say, tourism. Just think, if we don't have our tourism, and also employment which is related to the tourism industry. So yeah, these are things that we have not thought of. We are only
Yeah.
talking about the ecosystem, but we don't think that we are on top of that ecosystem, and it's going
Yeah.
to come to us.
Coral reef destruction and carbon liberation back to the atmosphere are things that, I have definitely thought of, but I just learned something new, this idea about sound waves being affected. And you even saw that in the chat here. Somebody said, that's amazing. I had no idea. I'm in that camp as well. I had no idea that was part of that. So thank you very much for that. So shifting a little bit to human climate interactions. Now, your research bridges natural systems and human activity. In other words, us living in these ecosystems. Where do you see the clearest fingerprints of human influence in coastal and marine records today?
Okay, you can see human signatures everywhere, right from coastal oceans to the deep sea. Okay, uh, but I think some of the most clearest fingerprints that we're getting is from our coastlines, where increased coastal anoxia because of increased productivity, which is because of increased runoff, your continental runoff of nutrients coming out from industries, coming out from agricultural waste, coming out from just soil erosion, bringing in more phosphates and nitrates into the ocean, causing increased productivity, leading to depletion of oxygen. And when that happens, you have mass death of fishes. Okay, so your waters are becoming under concentrated in oxygen. Another thing is overfishing, trawling. This habitat destruction. We are reclaiming our mangroves from making them sediments to soil grounds. Okay, for so that it can be used and changed for land use. But habitat destruction. We are trawling our seabeds, which is destructing the breeding grounds, the nurseries. Another thing, I was just talking about ocean overfishing. We don't realize that when we are overfishing, an ecological niche gets empty, and that allows predators to come from somewhere else. Or it causes non-native species to invade and occupy there, destroying the entire food ecosystem, which obviously leads to dietary switch, loss of cultural livelihoods. And whenever there is increase in temperature, increase in ocean acidification, depletion of oxygen, increase in pollutants, um, the phytoplankton are known to give out toxins to protect themselves. And when that happens, there is a rise in harmful algal blooms, and this is all in our oceans close by, which is affecting the other marine life. And of course, we all know about microplastics in the food chain now entering the human food chain. So yeah.
Absolutely. Years ago, I lived in Baton Rouge, Louisiana, right along the edge of the Mississippi River. And when I would go and talk to elementary school kids, I would say, oh, pick up some crayons and draw a picture of the Mississippi River. And, kids would always grab for the blue crayon. And I'm like, no, no, no. If you're drawing the Mississippi River, you should pick up a brown crayon.
Okay.
Because literally the color of the river is brown because of all the sediment that you're talking about, all those nutrients that have come down from the Midwest. And it causes, just like you were saying, that enormous dead zone in the Gulf of Mexico. We see, red tides and those sort of, algal blooms that happen. And it is really a problem. I've experienced that firsthand. And then, of course, also we had the Deepwater Horizon oil spill down
Yes.
there, years ago, which still
Yes.
has has impacts to this day. So, well, I know a lot of your studies have focused extensively in the Indian Ocean region. Tell us a little bit about what makes that region especially important or vulnerable in the global climate system, and what implications there are for studies in the Pacific or Atlantic Oceans that border the United States.
The Indian Ocean plays a very important role in the global ocean system. It occupies about 20% of the Earth's surface waters, and it actually works as a hub, a central hub of climate regulation. And you'll be surprised, actually, there have been news in the past where the Indian Ocean is completely hot right now. It has reached unprecedented levels with about 3 degrees increase in, the sea surface temperature than, one of the largest known in recent times. What happens is there is a global conveyor belt. One thing which is different in the Indian Ocean is it is landlocked to the north. The waters which are heated up in the equatorial Indian Ocean, they move south around the African continent, and they move into the Atlantic Ocean. So Atlantic Ocean gets its warm waters from the tropical Indian Ocean, allowing for seasons to come in, allowing for warmer seasons to come in. Okay, this water goes to the north, and then it downwells, and it again brings in all the nutrients. It takes in oxygen from the surface water down to the ocean, and it comes back to it actually, most of the water comes back through the Indian Ocean through flow. That is the Indo-Pacific waters. It goes into the Pacific, and then that water through the Pacific waters, so most of the warm waters in the Pacific get injected into the Indian Ocean. We know about the Indian Ocean dipole, or the El Nino Southern Oscillations. El Nino Southern Oscillations, one major part of it is in the Indian Ocean, the other one is in the American Pacific. So whatever is happening in the El Nino Southern Ocean, India and Indian Ocean plays a major role in it. Similarly, you have something what is called the Madden-Julian Oscillation, which is a major atmospheric disturbance. Atmospheric scientists will be able to talk better before. They are characterized by an eastward moving pulse of clouds which bring rains to the Atlantic. So whenever there are strong trade winds, these clouds which are formed in the Indian Ocean are moved to the Atlantic, bringing in rain and also maybe hurricanes. So when there is more and more heat getting trapped in the Indian Ocean, it is disrupting that. It is not allowing these clouds to move that side. And so if you see, Indian Ocean is central, because that is where the most global warm pool occurs. And that's why it plays a major role in global ocean circulation and climate.
So I'm thinking there might be stronger similarities with, say, the Gulf of Mexico. Is it sort of a trapped pool of water as opposed to the Atlantic or the Pacific, where we have currents moving up and down, the coast of the U.S.? Yeah.
Yes. But then again, if you see the Gulf of Mexico, it is a Gulf. Okay. Right. But if you see the Indian Ocean, it is a major part of the global conveyor belt, or the global ocean circulation.
Absolutely. Well, you've participated in multiple oceanographic expeditions and long-term coastal studies. How do you think field-based science can more effectively inform coastal management and policy decisions?
Coastal studies happened to me because I did my PhD in Oceanographic Institute, where I had regular access to ships, and I could go out at sea and collect samples. But when I took a break and moved to an academic institution where I couldn't get vessels, I started looking at coastal strips, which were not so well studied. And that is when I saw this, and I started working. I went to the coast just for basic science, trying to understand what foraminifera are there, how have they changed with time. And when I started doing that, I started seeing that they were records which were very recent in time. When I could date them, I could see past 100 years data, past 50 years data, past 200 years data, where humans have a fingerprint. And that gave me a very good record of being able to see correlate historical data from government offices or instrumental records and correlate it with what was happening with the ecosystems. So that is where I started calling it human climate interactions, because there was things I could see changing in the ecosystem. One example I'll give you was when I was working in Goa, central west coast of India. I was able to identify that the mining reject, or soils which run from the mining industry, were disrupting the photosynthetic the productivity. The food chain was being disrupted, leading to collapse of ecosystems, benthic ecosystems. And this work got picked up by the assembly, the Goan parliament, what do you say, the government. Okay, it was picked up, and they used this information to change ore handling methods. They said no more keeping the reject outside so that it can be flown into the ocean by winds and water. So it brought out a policy decision. You just needed a learned person in the government to identify this, that it can help improve. Otherwise, it was just mining industry flourishing and the fishing industry collapsing. Another thing, when I was working, I saw in another estuary, I saw that there was industrial effluents being released into the ocean, whereas it was we didn't know what impact it was having. Just looking at foraminifera told me that the lower ecosystem was all gone. The base of the food chain had collapsed. So trying to make, when you report this as a scientist, maybe as a scientist, you don't have a say to talk to, lawyers, but it can get picked up from policymakers. For example, look at the IPCC, the Intergovernmental Panel on Climate Change. It is nothing but a policy-making body which makes policies on the basis of thousands and thousands of research reports which are coming from different places. I was able to, while working, I was able to identify how local people were involved in destroying their own breeding grounds by participating in sand mining. Just by telling them, by looking at past climate records, telling them, no, the climate has not changed, but some human intervention has changed, which is disrupting your ecosystems. Just by publishing this and keeping it out, talking to local population, I think they fight for their own rights. I have people going out and fighting for protecting their own ecosystems, going to the court, using scientific data for bringing justice to themselves. So I think this helps. And as a scientist, my work is to communicate the results that I get. And I'm sure people who want to make a change do. And maybe, one day you get a voice in the policy. That's it.
Absolutely. No, that is fascinating for sure. Well, next, I'd like to switch to a little bit about your personal journey. Now, you've navigated science as a woman across multiple institutions, countries, and career stages. What progress have you seen, and where do you think real structural change is still needed?
Oh, I think there's a huge progress. I think when I joined the National Institute of Oceanography, we started, the three of us who were girls in the geological oceanography, we actually got together and actually got a women's washroom. Okay, so there wasn't a women's washroom. So from that phase, now what I can see is there are more and more girls. Like if I look at uh, there is a statistics which say that more than 50% of the PhDs in earth sciences are now awarded to women. Okay, but if you look at them translating into jobs, of the total jobs in earth sciences, I think about 15 to 20% is taken up by women. I think there is, when I think of what structural change remains, one thing that I will always say, that we have come a long way, no doubt, but there needs to be a permanent setup of gender sensitization cells. It's been a very long time that men have been pitched against women and vice versa, where you've told that, you have to get it all and not give it to the other. It's important that we realize that we both have different skill sets to get to the table, and not just think about an individual's progress, but think about the progress of the institution that you belong to. When you work together, I think, because you have different skill sets and complementing them can bring, so there needs to be, otherwise I've actually seen, two examples I'll tell you. Recently, I was on a panel. I was convening the program. I was the one who had built it, created it. People had come together, and I was not in the panel discussion. There was someone else in the panel discussion, and that lady wouldn't come. And then there was this German who said, I cannot participate because, as a rule, my university needs me to have a woman on a panel. If there's no woman on the panel, I will not participate. And that is when I was forced to be on the panel. Why couldn't there be more women on the panel in the first place? Right? Um, and so sometimes making these changes, that pushing women into these positions, what happens is we do not see women, though there are 50% of women in research. I told you just 20% in leadership positions. And then they say, oh, there are no women with leadership qualities. It's important that we catch them young and we put them into, they're exposed to management training and junior leadership roles very young. There should be a structural change to pitch women with, to work with strong role models, be it men or women, and they should be made to take independent decisions, fail, recover, and again stand up in an early stage of their career, so that, and then there can be an ecosystem to cushion them, at least in the lower. So at least we have trained them at a young stage so that there is no, one very thing is, two things that I would say structural change apart from having these gender, sensitization cells is one, relaxation in past experience criteria or promotional criteria when women have taken breaks for childbirth or childcare. There needs to be a relaxation in that. And then have gender neutral, ethically strong monitoring of work progress, emphasizing their academic credibility over gender bias. You need to say, if you're academically strong, we have been, just, and yes, and making jobs target oriented than time oriented. Rather than saying be here from 9 to 5, it's better to say this is your target. As long as you're achieving it, we don't mind. So these are three major structural changes. And another thing is, it's not structural, it is something mental. There was a recent study which interested me, which said that women can take orders from men bosses, but women and men don't like to take orders from women bosses. So, somewhere if people just understand that, you're equals and you're going to have a man boss sometime. It doesn't, you need to make it human. Don't make it a man-centric or woman-centric society or workplace. Yeah. I think that should, it's again, I told you, gender sensitization cells.
Yeah, absolutely. Well, gosh, thinking back several years ago, I coached soils judging teams. And when I first started doing back when I was competing in the mid 90s, it was almost all men, right? And then we sort of got into a period of time where it was sort of mixed gender, men and women. And today, if you look at soils judging competitions, many teams feature mostly women. So I am seeing some progress there as well. And also, I might point out to our listeners, just progress in terms of academic publishing and editorial boards. If you go to Simago Journal Rank and take a look at some of the journals that are being published, they actually track the percentage of female authorship there. And you'll see those numbers are steadily trending up. So I think progress is being made, just as you've elucidated.
Yes, for sure.
You've talked about mentorship, and you supervise and mentor many early career researchers. What qualities do you try to cultivate in your students beyond technical expertise?
Okay. I don't know. Somehow I've been a woman magnet. One student passed out, a girl, 3 PhD students, they're girls. I don't know. I tend to pull in more women. I have no idea why. But one thing across the board, but I have had a lot of master students who are boys. And one thing that I tell them is try not to read other research findings. Okay. Because I try to tell them, first, look at your data, write down your observations, your inferences, and then, and then go out and read other papers or other findings. Because I have seen studies coming from different latitudes and different geographies, but having the same finding. People are replicating studies, and They are looking for pre-decided results in their data. So that what happens is that kills innovation. That kills an opportunity for different thinking or different finding. So one thing that I tell my students is innovation and novelty is lost in that. So that is one thing. Second thing, which is most importantly, I teach the students the art of reference writing. Referencing is so important. And I also tell them that please go out, when you go out to conferences, try to meet the people you're citing. So you know what backgrounds they come from, what moral, ethical, scientific robustness that come from, what is the group that they come from. It also helps networking. I promote loyalty to students. Loyalty in students. One, to their work. Please do not fabricate data. Bring realistic data. Loyalty to their desks. Clean it up, maintain it, own it. And loyalty to their mentor who has helped them. I cultivate the culture to work as a team instead of competing amongst themselves. I teach them to build networks and support systems within their own generation. I make them independently handle my lab and guard it fiercely as if they won't get more if they lost it now. And I expose them to event management and project management skills and even accounting, because I'm trying to make them, independent thinkers and independent workers. I won't write their papers for life. So I want them to be independent and I want them to be stakeholders. And, for
Yeah.
me,
Yeah, absolutely. I've
partners.
often spoken with our faculty about the idea of being that professor that makes a difference, and we can all think back to that one person in our lives who had a meaningful, tangible impact, right? I mean, we all have that person. Taking an interest in students, not just as students, but as people. I can remember weddings that I've been to and holding their children in my arms for the first time and being there, following them throughout their careers and continuing the mentorship long after they've left the classroom. I think that is a key aspect of mentorship as well.
Yes. Yes.
One thing that I have really enjoyed getting to know about you is your love and passion for science communication, right? Now, you've written popular science articles, you've appeared in podcasts, you've led outreach efforts, all kinds of things. Why does science communication matter so deeply to you? And what do scientists often get wrong about scientific communication?
Mm, a very, I was, I always liked science journal. I like journalism. I like to communicate. And one thing which inspired and, strengthened this want to communicate science as an academician or as a scientist. The problem is, when I was in Germany, I went there and I saw this group which had come back from an expedition in the Central Asian mountains, and they had made a video about their expedition, of how they collected samples, how they traveled, how they survived climate, and got kind of samples and came back. And this documentary was screened on national television in Germany. And when I said, why? And oh, you can do that. They said, of course, it is a must for us because research is funded by the taxpayers' money. So the taxpayer needs to know where the money is going and what use it is being put to. And I carried it very, very strong. I think I'm one of those very few persons, and even probably women, who have got the opportunity of several fellowships, exposure, and traveled across the world, got lots of different experiences. And so I surely feel that this was also taxpayers' money giving in what I was doing. The problem with scientists is they are very good scientists, but there are two reasons. One, maybe they are not very good communicators, maybe writing or oral or something. So that keeps them away from interacting. Another thing is they speak in jargons,
Mhm.
and that is not understood. So I feel, but whenever I have spoken or even in class, my students, even my teachers have come up and say, oh, you should teach, or you should, I have seen people getting inspired to enter oceanography, geology, climate change. So I think I can inspire. So I've been blessed to be, maybe I say, that is what people tell me, that I'm blessed to have good oratory skills or writing skills. So I think it is good. You must do it more often. One, to attract the youth to STEM, keep them interested, building awareness for having responsible public actions in maintaining your environment, climate, promoting scientific temperament amongst the common public. So I think, yes, this is what drives me, because I think I have been lucky enough. And so before I'm gone, I should give back my knowledge to society before it's gone with me.
Do you find challenges with people conflating opinion, which everyone has, with scientific facts?
Um, you will always have it. Yes, I do find people. There are so many people who defy climate change, and or when they speak to me, I just have to say that I'm just keeping facts in front of you.
Mhm.
I'm not emotionally opinionated. I don't stick to my opinions, and I just bring out facts and leave it for people to interpret. It is for them. Yeah, I'm talking about science. I'm not talking about
Right.
feelings. So
Yep,
it's data backed information that I speak of or communicate.
absolutely. Water freezes at the same temperature all over the world, no matter what you want to say about it. So that's right.
Yes.
Well, your work blends geology, chemistry, biology, remote sensing, social relevance, so many different things. How do you approach interdisciplinarity and all of this collaboration without losing depth?
Okay. Like I said before, that Earth system sciences is an interdisciplinary science. And knowledge of all these basic sciences, I think, actually adds up to the depth of my research. Okay. It prevents me from being biased in this approach. You know, that as a geologist, I look only at the rocks. But oh, those rocks are mediated by biology. They are mediated by the chemistry of the water. They are mediated by the different processes, the physics of the dynamics. So, it having this interdisciplinariness keeps me being unbiased. It helps me see the other aspect of the other sciences. Remote sensing is a tool, so it helps me look at, collect spatio-temporal data collection over large areas, and that it becomes possible and it is easy. So when I add it to my skill sets, it only strengthens my research. Though my education encompasses all these subjects and training, specialization kills. I believe I can not be a specialist in everything. So if I want to bring depth, it is better that I restrict myself to my specialization and rather collaborate people who are good in their own sciences, making the research more knowledge based and which has got depth. And that's why I said I've always wanted my science to be socially relevant. So even when I do basic science research, I tend to see what is the social relevance of my research. And when I do that, it also increases the chances of funding. So I think, yeah, collaboration, and yeah, I don't think it dilutes me. Rather, I think it makes me more robust and aware that I can't know all, and it's good to collaborate.
Those multiple perspectives. I often think about humanity and these perspectives in terms of threads in the tapestry of humanity. And if all those perspectives looked the same, the finished tapestry would be drab and uninspiring. I think where we really gain strength in humanity is to have different perspective, different lenses, different backgrounds, and pull all of that together for this multidisciplinary view on things. That's what makes us really strong. Well, let's look ahead just a little bit. As a Fulbright Column Climate Fellow working internationally, what questions or challenges are you most excited to tackle next? And what gives you hope in climate science today moving forward?
Mm, okay. As a Fulbright Kalam, this opportunity to work across, different boundaries of nations, like I said, oceans and atmosphere is one. It is globally connected. But though it is globally connected, it is you can have one data point to say when it is when it's averaged over space. But every ocean regionally is different. It behaves differently. So if I'm working in ocean acidification here, and my host is working in ocean acidification, like Michael Martinez Colon, who's here, he's working on ocean acidification. His data set and the processes which affect that data set are different than the ones I'm doing. So when I look at this, I look at being parts of a huge jigsaw puzzle, that as long as we don't come together, we will not be able to understand the global picture, the entire phenomena. And that's how I look at this opportunity of being in the Fulbright Kalam Fellowship, that I bring in to the table my own experiences and data sets, and that's what happens from the others. And so that is now, what are the challenges that I want to look at? I think the challenges, the research interest will keep changing, because with more and more scientific data coming in, the questions are changing every day, because you have a better understanding of the process. So your questions are changing. So, but the challenges that I right now look at is how to make this challenge, whatever information that I get, how do I use that data or understanding of climate change be implemented into policy, make it reach grassroots level. Scientific research keep changing as scientific data is produced, but the challenges I want to take on is to translate scientific understanding to implementation of policy through people's participation.
Absolutely.
And there was one question that you said, that what brings hope? I think, like I just said, spatiotemporal data availability. Initially, when I was in a research institution, I could go and collect my own samples. Now I'm somewhere else, but because of global networking, social media, there is more access to samples, knowledge, skills, interaction, and that's what I think I am very hopeful about. Now there's more data available and people are ready to share. And yeah, that's the hope that I feel, that yes, that's what makes this climate. Another thing is, climate is not just atmosphere or data. Climate science also has to do with impacts. Like I'm looking at 16 sectors of uh, climate change, impacting climate, 16 sectors which climate change impacts: insurance, biodiversity, water, food security, and energy. There's so many. So the fact that different expertise, people with different disciplines are looking at climate, gives me hope towards climate studies.
Excellent. That is wonderful. And hope is a good thing to conclude upon this morning. Dr. Panchang, on behalf of the Fulbright Association, the Indian Interest Group, thank you so very much for your time and perspectives today. You've left us inspired and richer for being blessed by this discussion.
Thank you. Thank you. Thank you for being so thoughtful with your questions. Compliments to you.
Thank you so much. And at this time, I'd like to open this chat to questions from the audience. Feel free to turn on your video and ask your question.
I just want to let everyone know this is being recorded. So if you don't want to be on camera, just go ahead and ask your question without coming on camera. Okay. Dr. Weindorf, go ahead.
Yes, please go ahead with the questions. Any questions from the audience we may have? Buddy, I think
I have a question. May
yes,
I
please
go ahead?
Yes, please go ahead.
This was such a wonderful talk, Dr. Panchang, because it was on so many different things, including, gender differences, science, communication, climate, and from so many different perspectives, earth, water, and so on. My question to you, this is a new area I'm getting into. I should tell you, I'm from a school of communication at the University of Miami, and I've become very interested in, and I've taught a course actually in it, in indigenous people's stewardship of the environment. And we just did interviews all around the world with indigenous people. And there are so many, the epistemology is one of reciprocity and relationship with nature, and how they've preserved. And being from India, I'm sure you know about the sacred forests and all of the other things.
Sacred groves,
and
yes.
I come from a social change perspective. So for me, it's my classes are more about how maybe we can go into communities and create participation and ownership of this problem. Just like you said, you put out the data, then communities on the sand mining issue, for example. So do you think there's a role? I mean, obviously this is a human-induced climate change. I mean, that's, spoken about all the time. And there's something about us human beings today where we are reckless with the way we deal with the environment. I hope I'm not offending anybody, but this is my opinion. And when I look at the indigenous communities and the number of interviews we've done and the readings that I gave my students and, so many other experiences, I feel there's so much to learn from them. And yet we are not, is it impossible to do that in a neoliberal greedy capitalism of today? I'm sorry.
No, we're talking about sustainability, and sustainability, the definition of sustainability is to preserve the resources, use it for your own needs, and preserve it for the generations to come. So lifestyle changes are very important. It's a more ethical issue. I think there's so much of policy in place to protect rights, but it's important that more and more people fight to get these policies implemented. Okay, I think that is where we need more and more voices and people standing. It's not difficult at all. Most of our governments have the policy in place. I think it is the enforcement of policy that matters here, and we all know what is right and what is wrong. So it's an ethical question.
And I would add to that also, the younger generation today, they have a strong sense of moral compass and ethical practices.
Yes.
You see them wanting to recycle and, pay for sustainably sourced materials. I mean, these are the kinds of things that people in their 20s and 30s, they're really laser focused on this. I think we have a real opportunity to work with them in that regard and let them be leaders that all of society can benefit from.
The only thing is, these young, like I was telling you, it's important to have morally and ethically strong bodies regulating this, because it will be very easy that someone young who's just about to start their career and they start showing off the moral compass, there'll be people who will shoot down their careers. So it's really important that it's ethics. It's finally
it's ethics, but the ethics, even if people and young people certainly in my classes talk about it a lot, but even if the policy is there, the problem is whether governments are willing to implement that policy, whether it remains on paper. And there are many cases, and it's a politically charged issue, so I won't bring it up. But this is a major issue. Policies are often on paper, and it's very difficult to get them implemented. But thank you so much. I do believe that more among young people, more knowledge about indigenous knowledge systems and their stewardship of the environment would be very useful. And there's a little bit of a rise in that. There's a little bit of more awareness of it, and I'm hoping that it'll increase.
Yes. Thank you so much.
Any other questions from the audience? Well, I will turn it over, Merlani, to you to wrap things up if you'd like.
Thank you. I thank you, Dr. Weindorf. Thank you, Dr. Panchang and Dr. Swami Kanu, for hosting this session, for your insight, and for making this so real for us, just bringing that connection back to it isn't just the millions, something that's millions of years old, but you just made it so something that we would engage with on a day-to-day basis, and it's relevant to all of us. I just want to invite all of you and to let y'all know we have 2 more sessions this month. Our next session is our Visions and Voices, Dialogues Across Culture, Health and Ethics. It's with Dr. Rima Sehgal on it's next Saturday, so is that May 16th. at same time. And then the last session for this term will be on May 30th. It's our last Chai Chat series session, and that will be on Haibun Writing Workshop. Will be the Haibun Writing Workshop. So I hope to see all of y'all there, and have a wonderful weekend. And thank y'all all for being with us today.
Thank you so much.
Thank
Rajani,
you.
for this
Thank you.
opportunity.
Thank you.
And, yeah, thank you for a nice morning.
Yeah, thank you.
Yeah, bye-bye.
Bye bye, everyone.